Hey everybody, this is Jerry. I'm back again. I'm going to talk today and show you briefly about how we're going to drill some holes in the freewheel clutch and the freewheel sprocket, and we're going to match it up to the aluminum sprocket. If you didn't watch my last two videos, make sure you take a look at those videos and listen and watch and listen to what I have to say in those, because that's a prelude to this video that I'm doing here now. The first one's called freewheel versus sprag clutch, and the last one I think is called freewheel to sprocket. Okay, so let me get the camera pointed over to the drill press over there, and then we'll show you what we're going to do next. Okay, now we're back over to the drill press, and as you can see, the freewheel sprocket is mounted onto the drill press. Today here in Texas we're up to about 100 degrees. It's one of the hottest days so far this year, but we're going to work through it. So let me go over to the drill press and let me point out a few things for those of you who just want to know. Let me put my leather over top of me, because at some point when I start drilling, I don't like aluminum chips getting all over me. Alright, so what we're seeing here is, this is the sprocket. On each side there are clamps. They're clamped down, and if you never worked with these clamps before, maybe you can see this in a video, hopefully you can, but this is what's underneath the table. A rectangular piece that's threaded in the middle, and it goes underneath. Okay, and then the bolt obviously threads through, and you just tighten it up, and as you're tightening it up, it clamps to whatever work piece, in this case the sprocket's being pressed down to the table, right? Okay. I'm going to eventually go to 1/4 inch, because we're going to drill 1/4 inch holes, 1, 2, 3, 4 into this sprocket. But we're going to start out with a smaller drill bit and chip away at a smaller hole and then come back with this. So let's see how this works out. I'm going to try to throw a little cutting fluid on this. This particular freewheel sprocket is stainless steel, so it's a little bit harder to cut through than just regular soft steel. Right, so let's see what we get here. Helps if I get a little power first. The speed's a little higher than I would like, so I'm going to bring it down just a little. Okay, we're about 850 RPMs. Let's see how it cuts here. Sorry if my hand's in the way. This is an old drill press, hard to... Yeah, so this bit doesn't even want to cut into this. A lot of times these sprockets are hardened, so this sprocket's probably got some chromium in it, and it might even have some nickel in it, and that makes for a very tough work piece to drill into. I got some cobalt bits, but I don't know if they're going to go through this. I may have to get some carbide bits. So let me stop the video, and I'll come back when I just get the bit starting to cut into the sprocket, and I'll run some more video, okay? Okay, I managed to find a carbide tipped bit. I got a few of those in the toolbox and found a relatively new one. So we're going to go ahead and start this up again, and I think we're going to get some good chipping going on. Let's see if we can punch a hole through this. Okay, I got a little cutting fluid on there already. I'm about 600 RPMs on the drill press, and let's see what we get here. Okay, so that's a good sound, because that means it's cut, and I see a little bit of chipping going on. Let me just wipe away some. Yep, got a good little hole going on. A little more cutting fluid, run it down right on top of the bit, and the bit will drop it right in the hole. Okay, so here we go. Do it again. Now these bits, you know, a lot of times they wear out fast if you're running at the wrong speeds and not using cutting fluid. The only thing I don't like about this particular bits that I got is it doesn't have a beveled sight on it when you put it up into the chuck, so if you're not careful, it will slip in the chuck. Yeah, it's having a hard time getting through. We got a hole started, but it's not having a hard time getting through. Let me adjust the speed. I'll bring the speed down even a little more and see what happens. Down around 500 RPMs. I don't think we can go much slower with this drill press. We throw just a little more cutting fluid on here. Here we go. Pretty sure the bit's slipping in the chuck, pushing up into it. There we go. Give it a little heat. That's what it takes. You gotta pierce that layer. That's the way it is with hard materials. There's like a layer you gotta pierce through. There's like a certain speed. You gotta be right on the button with the speed. If your speed is off, that bit will not work. So I slowed the speed down, add a little more pressure, and it worked. There you can see that the bit just got stuck. And man, I got lucky on this one. It didn't get stuck in the hole. So this bit, as I said, you can't tell in the video, but this is just a regular high-speed steel bit, and the edges of the shank are beveled, and that keeps it from spinning in the chuck. This particular carbide bit, tipped bit that I got, it doesn't have the beveled edges on them, so it's going to spin in the chuck. I mean, who makes crap like that? I don't know, but I didn't know that buying them. I just assumed they were going to be, that the shank was going to be beveled properly. I was wrong. And, you know, this is a pain in the butt, dealing with a bit that's going to move around in the chuck. Got stuck again. Alright, we're through. Okay, so that's initially the first hole. We're going to go to a bigger one. Okay, I managed to find a 1/4 inch cold carbide tip bit. Looks like it's been used before. It's got a lot of heat in. I can see some heat's already been put into the tip from some previous work, so I'm not sure this is going to cut through, but let's give it a shot. This is the right size I'm looking for. They bring the speed down really slow here. Below 600. Okay, we're down to 540, 520. Here we go. Let's see what happens. Good deal. Punched right through. Okay, so that bit was still a lot better than I thought it was. Alright, so there we go, guys. There's the first hole. I got to do 3 more of those. Okay? And I love this stuff. It's nothing like aluminum. It chips really good. It doesn't flake all over the place. It's a beautiful thing. Alright, so we're back. And I've rotated the sprocket for the next hole. And right now I'm just going to use a wrench and tighten down the clamps very carefully so the workpiece doesn't move, right? We don't want the workpiece to move. So we're just going to tighten this down really careful like. Keep an eye on the workpiece, make sure it's not moving around. This is a really small drill press, so you know, if I crank on this really hard, I can actually move the whole drill press, not that heavy. Alright, so this is pretty good, tighten. Alright. Let me throw a little cutting fluid on the carbide bit. A little bit on the workpiece, looking good. And you know what? This time I went right with the 1/4 inch carbide tip bit, and we're going to see if it cuts through. Okay, so we're still at about 520 RPMs, and let's see how she cuts. May not punch through here. This is definitely the hardest part, getting through the initial material and just getting it to chip without breaking the bit. So I'm going to stop it here for a moment, and what I'm going to do is I'm actually going to take the cutting fluid off. Okay, I already cut into it a little bit, so that's a good sign. Alright, that's good. So this bit's doing a pretty good job, and just a little dab of cutting fluid right on there. There we go. There she goes, a little bit of smoke. Okay, so we got the tip to cut through. Now we're going to add just a little bit of fluid. Sometimes you put cutting fluid on too early, you don't get enough heat and it won't cut. Now we got a cut going, add the fluid, now we're rolling. Stop right there a little bit because we're getting a little bit of smoke and a little too much heat. Okay, just a little bit more cutting fluid. Alright, we're through. Okay. Yeah, the initial cut is always a really challenge with this hardened material. Alright, so that's our second hole. I'll stop the video, rotate the sprocket, and I hope you guys can appreciate the process of what it takes when you only got a drill press. Right? The CNC machine, if you could get your workpiece properly clamped, it would just go through and do all the work once you get the programming in there. But with this old school approach, you have to stop, rotate the workpiece manually, and go on to the next cut. Okay, we're on to the next hole. I moved the sprocket. This is the third hole of 4 that I got to cut. And I'm going to fire this puppy up. See if we can just do a little bit of a cut with no fluid, which I know some of you are going to cringe. But we're going to try to put a little heat into the workpiece, and once you get any kind of cut going, then I'll stop and put some cutting fluid on it. So the tip, this is an initial cut. There's no smoke coming off this bit yet, so we need a little more heat. There we go. You can hear that. I can see a little bit of heat coming off the bit. Now we're going to add just a little bit of cutting fluid into the hole. I'm at 520 RPMs in this little drill press. Let's see what she does. Okay. Okay, he's having a hard time cutting right there. Let me wipe off some of the little bit of chip that's there. Okay, I'm also going to wipe away the cutting fluid and get rid of any chips that may be in the hole. And then we're going to just go dry here a little bit. Yeah, having a hard time punching through here. This bit's kind of heated up. Back and forth. Pretty good. Just a little bit of fluid, just a dab of fluid here. A little bit of fluid. There we go. Okay. Just a little bit more fluid in the hole. We're almost through. Bit got stuck. Try to approach this nice and easy. Okay, we're through. Alright, that's the third hole. This poor little drill press, I'm certainly pushing it to its limit here. It's not really designed to put all this kind of pressure on it. Okay, on to the last hole. I got the sprocket turned and clamped back down. We're on our last hole. We've got 1, 2, 3. We're going to the last one right here. And let's hope this bit will hold up to the job at hand here. All right. Here we go. So I'm just going to push this until I get enough heat into the bit and the metal. I'm going to stop right there. I can feel that the bit is slipping up into the chuck. Okay. Okay, got some chipping going. Keep the pressure on. Just chipping. Not enough heat to really be concerned about at the moment. A little smoke coming off of there, but not a lot. You know, with this type of material, you hit little patches of nickel or little patches of chromium or whatever they're using to harden the material, right? This alloy. And you can tell when you're going through a different type of, a little bit of different mix of material. It's very interesting. Sorry, my hand's in the way. I gotta put pressure on the quill here. I had some bits before where the entire bit is carbide, but they just, eventually they're gonna go bad. And with carbide, I'm not sure you can sharpen it or not. I'm not sure how that works. Maybe you can. I'm not sure. There we go. A little bit of fluid, a little bit right down to the right spot. Stop right there. Matching speed and matching temperature is what it's all about with this hard materials. There are charts to do it. Now, I'll admit I don't have the chart in front of me. I got a little lazy. All right, last hole's been punched through, looking good. And just trying to keep any of the chips from getting into the bearing itself, because then you got little pieces of chips getting into the ball bearings, and that'll ruin it really good. So I managed to keep the chips off the bearing. It looks like pretty good here, so we're all right. Okay. So next, I'm just going to clean up the sprocket a little bit on the other side, because it's going to have some a little bit of sharp edges to it. And then I'm going to stop the video for now, and I'm going to match up these 4 holes to the aluminum sprocket. And the aluminum sprocket, I don't need carbide bit to punch through that, right? That's a piece of cake. So remember, we're matching these 2 up, right? So next, this is going to go on the table, match up with the holes that are onto this sprocket here, and then eventually we'll bolt them together. Okay, now so I have the freewheel sprocket on top of the aluminum sprocket, and I've got them clamped together. I know the light's a little bad back there on the right side here, but this is just, now I'm just drilling through aluminum, so the hole already exists for the freewheel sprocket, and I'm just going to drill right through that existing hole right into the aluminum sprocket, so we know we have a good match. And then I'll throw a bolt through that hole. Let's just cut this hole real quick, should be really quick. Okay. Definitely concerned about getting aluminum chips into the bearing, but looks like we're okay here. Okay, so the next thing, I'll take this off. I'm going to put a bolt hole, or just put a bolt through the 2 holes now. There's one in the freewheel and one in the aluminum sprocket. At this point, I'll put a 1/4 inch bolt through there, tighten it down, and I'll know that I'm going to have a really good center point. I'll drill the other hole on this side, put a bolt through that, and the rest of these 2 holes, I don't even have to do them on the drill press. I can just stick them on a piece of wood on the floor, use a hand drill, and just punch through them real quick, because I'll know at that point I'm centered. Okay, drilling the second hole in the aluminum sprocket with the freewheel also right on top of it. I got a bolt hole, and I already got a bolt through the first hole I cut. So now this is matched up. I looked at the other side, make sure it was centered, and now I'm going to go ahead and punch the second hole. Pretty quick through aluminum. And there we go. Okay, so now I'll put a bolt through that hole, and I know that we're centered. I'll take a good look at the other side, make sure it's not moving around, bolt it down really good, and then just punch these 2 extra holes with a hand drill with a piece of wood on the other side. I don't have to sit here and get it perfectly clamped up every time now. Okay. Okay, so we finished drilling the 2 holes. There's the other side. And we got 2 more holes to drill, but we're not going to do those on the drill press. We don't have to. Okay, so now you can see these 2 pieces are mated together. Right, there's a bolt here through the hole I drilled on the drill press. And here's the other bolt on the other side. Right, we just have a lock washer and a nut, and a lock washer and a nut. Okay, maybe hard to tell in this video, but it's centered now. I took a good look at this. It's centered in the middle of the sprocket. So now I'm just going to stick it on the floor on a piece of wood, okay, and drill the other 2 holes. Right, let's see what we got here. We got a hole right here, at the bottom. Kind of hard to tell with the light here, but that was a hole there, and there's a hole up here. Okay, so that's going to be really easy to do. Once I'm done drilling that, we'll put the adapter in, slide it on the gearbox, and we got ourselves a freewheeling. As a matter of fact, right now, what you're going to notice is, let me get this in front of the camera the right way, so you can get my hand in here. Okay, look at that, guys. A freewheel big sprocket. That's what we were after, right? Remember when we started this was just a regular old sprocket, right? And there was no way it could freewheel, but now it can freewheel. Look at that. That's a beautiful thing. Okay. Alright, so let me finish this up, get it on the gearbox, we'll run a little more video. Okay, now that we've gotten all 4 bolts, there they are, 1, 2, 3, 4. Lock washers and nuts on the other side, right? And looks fairly well centered here. We'll know for sure whether or not this all worked out right once we put it on the gearbox. If it's not centered really well, what you're going to notice, what will happen is that the sprocket will oscillate a little bit like this, right? As it's turning, okay, it'll have a little oscillation to it. And if it has an oscillation, that means we didn't get it centered properly. Okay. I had a comment from one of my subscribers and viewers, and he said, "Why didn't you use a lathe?" He's 100% right. And I would love to use a lathe, and if I get the money up, a lathe would be great. And I've talked about CNC mill, and a lathe in the future would be really nice. And you know, local machine shops can get pretty pricey, and they can also take a lot of time. So I like to just get things done, and we had to do it on a drill press. But yeah, I want to thank the subscriber for taking the time to comment. I appreciate the comments, guys. Comment on the videos because, you know, I like to share with the YouTube community. Okay. So anyway, here we go, guys. Look at this. Huh? How good is that? I'll stand back here just a little bit, get a better light. Look at this. Is that awesome or what? Freewheel sprocket. So pretty cool stuff. This was actually kind of fun to do. Okay. Driving directions that way. Winding the weight back up this way. Okay, so we got that done. The next thing I'm going to do is start working on the big winding wheel, which I'm still contemplating some designs. That's a major undertaking, but we're going to get going on that. Try to finalize the design and what materials are going to be needed, and then hopefully we can get this baby running here sooner rather than later. All right, guys, thanks for hanging with me. Subscribe to my YouTube channel. Thumbs up on the video. I appreciate any comments. I'll take care and God bless.